I'll do it to the computer and I'll upload it later.
All right. This is going to be very informal. Like I said earlier, I'm leaving the country tomorrow, so I'm in the middle of a bunch of packing stuff. But I thought it'd be cool to talk about a new library that we developed at Amperity end of last year, basically. So near the end of December, Amperity has something that we jokingly call the Santa Sprint, which is kind of some dead time at the end of the year. We're in code freeze, so not a lot is happening. Lots of people are on vacation, or at our tenants are on vacation too. So it's pretty quiet, and engineers get a chance to kind of work on something that they choose that kind of is something that they have wanted to see done or been interested in, but doesn't fit into our normal kind of cadence. And this last year, I was very top of mind was a security issue that had just happened at the end of November, which is Log4Shell. And for those of you who somehow are not aware of this critical vulnerability, there was this really obscure use case functionality built into the ubiquitous logging library in Java, Log4j, that if you manage to sneak the right string into someone's log statement, which, as you can imagine, is not that challenging to do for lots and lots and lots of systems, then your Java process would connect to an LDAP server of the attacker's choice, download class files from it, and then execute the code in your JVM, which is horrifying on a number of levels. But this is a real feature that was built, JNDI, that was built into Log4j, and tons and tons and tons of people, huge amounts of the internet were vulnerable to this. And it was a 0 day, so people just found out, and suddenly everyone had to scramble. Fortunately, Amperity was not impacted, but it did get me to take another look at the way we were doing logging at the company. And that was a good motivation to try and think of maybe there's an opportunity to do something better here. And the state of the art for us at the time, this early December timeframe, there were 3 logging libraries in play at Amperity. One was a Clojure library called Timber, which some of you might have heard of. The authors built a bunch of other stuff, and we're using that in a couple places because being in Clojure meant we could integrate it nicely with our other observability tooling and get the advantage of some nice dynamic context collection and stuff like that. The downside was that only really worked for our Clojure code. So we also ran Logback, which is a native implementation of SLF4j in Java. SLF4j is kind of the successor to Log4j in a number of ways, but it just tries to provide a standard set of APIs, and then you plug in the backend of your choice, one of which could be Log4j, but in our case was Logback. I said there were 3 libraries, and that's because at Amperity we do a ton of large data processing jobs, and those run on a system called Apache Spark. And unfortunately, Spark bundles Log4j into it, so you really don't have a lot of options. You're kind of forced to play with the host environment you're in. So in our Spark jobs, logging would go through Log4j. For better or worse, the version we're running was too old to be vulnerable in Log4Shell, which is good, but not a great feeling. This was a pretty messy situation, and the way that Timber hooked into our other stuff was pretty gross. So I kind of thought, the actual things we want our logging framework to do is not that complicated. So what, we're using a tiny fraction of what's available in the, when I checked earlier, 200,000 lines of Java in Log4j, or I think roughly 80 or so thousand in Logback. And there's just tons of surface area there we're not using. What's the next 0 day going to be? And also, we still want the nice things we get from Timber, but just better integrated with the rest of our stuff. So to that end, I started writing a library called Dialog. And there's a pretty good article. I mean, there's tons of articles on Log4Shell. If you guys want to learn more about how exactly that all went down. But after a week or two of hacking, it turns out, yes, actually, there's not a lot of code you need to do the things that we were doing with our logging framework. But the challenge was like, how can we actually integrate this well with all of the other code we're using? So the result, I think, turned out really well. Dialog is an attempt to be just enough logging and still have the flexibility we needed to extend it in arbitrary ways, but only the ones we need, as opposed to those extensions having to be built into the logging framework itself. So it accomplishes this, I think, in two main ways. One is this, it's configured in Arrow, which is effectively an Eden file that gets read by the Juxt Arrow library, which if you haven't heard of, highly recommend. It's really cool. Also extremely small, so tiny surface area. But what it gives you is a bunch of reader macros you can use in an Eden file to write configuration that gets to do things like reference the environment or format strings. So a little bit of tooling, and significantly, it gives you this profile mechanism, which lets you choose, I'm in prod, or I'm in dev, or I'm running a REPL. And that turns out to be like 90% of what you need for configuring something like a logging framework without it getting in the way and being a ton of custom logic built into the logging library itself. So there's an example file which probably does a better job of explaining this than I will. So the file itself is just Eden. You drop it somewhere on your class path. When the logging system gets initialized, it'll go and find it. So obviously Dialog doesn't ship with one of these. You have to drop it in, and I'll show what Amperity's actual like real logging config looks like in a little bit. And so that profile mechanism turns out to be really helpful because Dialog will read this file with profile set to either the dialog.profile JVM property or dialog profile as an environment variable. So super easy to configure this no matter what kind of environment you're in. And that lets you do stuff like, say, when I'm in a REPL, I want to log at debug, but by default, log at info. And when I'm running in production, don't ever log things from org Apache HTTP, but by default, that's fine. And this turns out to be both very flexible and pretty sufficient for what we're doing. There's a lot more to Arrow, but like you don't really need it for something like a logging framework. Also feel free to like jump in at any point with questions. Happy to answer stuff. I'm probably going a mile a minute here. Okay, so the other main extension point that is super useful is because this is kind of a native Clojure thing, you can make references to other bits of code you'll have available in that JVM in order to both perform side effects at init time, and I'll show how we use this, but this actually also lets you modify the config. So this gets resolved to some function, and then that gets called with the current loaded config map, and whatever it returns is used as the new config map. So you can inject all kinds of extra stuff. This is Clojure, so this is just a regular map. You can stick whatever other keys you want into the logging config, however you want to make use of that particular functionality. And then the other one is this idea of middleware, and this is shamelessly stolen from Timber, which makes use of this concept as well. And so similarly, each of these symbols gets resolved and the namespace loaded at runtime. And then the way middleware works is they're called in succession with a logging event coming through the system. And similarly, they can make whatever changes they want to the event. You can also return nil to drop the event. So it's easy to write whatever predicate logic you want to handle the events coming through the logging system. And middleware can also be placed on individual outputs, which becomes important to us later. And then finally, these outputs are just a map of some ID to output spec. And there's a couple different types, a couple different formatters you can use with these outputs. But again, the idea was to stick with a pretty small set of fairly opinionated settings you can have here. We don't want it to be, infinitely flexible and have a ton of different code built into the logging framework itself. So a lot of the customizations you might make wind up getting pushed to stuff like the middleware. Okay, so that's kind of how you configure it. The config ultimately winds up, getting interpreted, and so this will have some defined value after it's been loaded with a certain profile. We could be referencing environment variables and stuff here. Then the other part I think that is really interesting about Dialog is that it is primarily built in Clojure, but there's a couple of Java pieces which make the integration with the rest of the ecosystem pretty seamless. And this is an area that we really lacked with our previous setup because Timber had to be initiated at boot time basically for the process. So you had to find a way to make sure that our logging core namespace, which did all that setup, got loaded by your process when it started, or else logging was just broken. And so there's a bunch of require amperity.logging.core with a big comment above it saying, do not remove this or logging will break. And that's not great developer ergonomics. So something a little more automatic and just works was also a goal here. And the way we did that is by hooking into SLF4J. So Dialog is also itself a implementation backend for SLF4J, which means you can drop it into your class path by adding a dependency on this, and then similar to including Logback or the Log4j backend or SLF4J simple, SLF4J will find this at runtime and bind to it, and it just works as long as it's on your class path somewhere. And that happens because at binding time, SLF4J, the very first time you try and load a logger, will try and resolve this class, static logger binder. And by providing an implementation of this that returns your specific implementation, SLF4J kind of wires things together, and you have code that's responsible for handing out these logger objects. And something that was important in this implementation, which we had been bitten by before, is that it turns out when you're running things at scale, logging happens a lot, very, very frequently when you consider all of, especially the things at debug and trace that you normally don't see in your logs because you're not logging at that level. So the implementations on the Java side had to be very, very performant in order to avoid the cost of shuttling that data over the kind of divide into Clojure, where we're talking about immutable maps with keywords and strings and values and stuff. So we've been bitten in the past by trying to use SLF4J Timber, which marries kind of everything into Timber in a way similar to this, except everything got sent to Timber, and then Timber was responsible for deciding, oh, this is a trace level log, I should drop it. And we actually saw very, very significant performance slowdowns in some of our jobs, which had the Parquet library, which apparently logs everything it's doing at trace level all the time in huge volume, and normally that just gets dropped before you see it. So there's some neat code in here around caching the level that was assigned to this logger, making sure we've got references into Clojure land, being able to bump the version of the cache when it's programmatically changed. I'm not going to get into all of that, but then half of this code is just boilerplate. So this is a good reminder of why I like working in Clojure and not Java as my primary gig. There's literally hundreds of lines of this SLF4J implementation, which is just various versions of calling is enabled and log message here. But banging out all that boilerplate and doing the binding like that has resulted in a very smooth kind of automatic logging experience for clients. Even if you don't provide the config file, there's a sensible default that spits things to standard out. But I thought it'd be cool to take a little walk through what the actual code is like. So I've got Clojure tools logging here. I've got, actually, I'll just show this. I've got dialog.logger, which is kind of the main client API namespace, loaded as log, Clojure tools logging as CTL, and then Clojure.string as stir. So by default, you got the same interface you're used to for Clojure tools logging. It's got a set of compatible macros there. So I can do infof. It formats the string. Okay, that's not crazy novel. I can do Clojure tools logging, and in this case, there's nothing magical here. Clojure tools logging bound to SLF4J because it found it on the class path, and then SLF4J bound to Dialog as the backend. So we don't have to reach in and do anything special with Clojure tools logging. The error putting in a throwable does what you expect. Here, Dialog has, this is the pretty formatter for the print outputter. And so it has the pretty version has some nice exception formatting, and you get the data structure and stuff for the X data. You can use Java util logging. Well, I mean, you wouldn't use it, but you might have a library that's using Java util, and that, of course, routes the way you'd expect. And then because we're backing SLF4J, hopefully we'd expect this to work. If any Java library that's built against SLF4J will route through Dialog. So even libraries that we're pulling in that are Java libraries benefit from this kind of formatting, and we have a cohesive experience for everything instead of maintaining parallel implementations in Logback XML and Timber formatting code, which is not super fun, let me tell you. And there's a couple different outputs and formatters, but the basic ones are all there. So print to standard error, standard output, write to a file, and one that we needed functionality for that we had actually already been maintaining an implementation of is a modern Syslog output. So we want to, in addition to printing our logs, write all the messages to Syslog so that they can get forwarded to a log aggregation tool we use called Logly. And that's where it gets pretty useful to be able to specify things differently. So if you look at this output, map of outputs here, there's 3 different profiles here. Test is using a null outputter, which just drops everything, which is useful when you want to suppress all the logging in your tests. There's REPL, which is what we were just looking at. So it's a print output. It's using the pretty formatter, and we're using short timestamps. So there's a minimum amount of functionality you can configure here. And then main, which is presumably what we'd run in prod, we're printing to standard out with the simple formatter, which is pretty, except without all the nice color coding and formatting stuff. We're not going to do extra padding. And then logly, like I said, we're writing to syslog, and we're going to filter to choose what we want to report off the host. But we're also going to write in JSON. And this turns out to be really useful to have the ability to have multiple formatters like this, because certainly when you're a human reading the logs, raw JSON with no padding is not the friendliest thing for you to consume, but it turns out to be very helpful to send structured logs to a tool that can make use of them. And so here is an example I pulled up of in our dev stack, looking at our syslog.appname maps to basically the system or service. So here we're looking at the workflow service logs, and you can see that I get a pretty nice comprehensive breakdown with a bunch of different fields here, and there's some sanitization of the keywords, but hopefully these are recognizable as dot separated qualified keywords in the event that's getting sent, in addition to the kind of normal fields you'd expect about the line and the host it's from and the logger name. And then some of those get sent as syslog fields. So we can see this was the workflow service, and it was also the second instance. So it was workflow.1, which gets sent as the process ID. And this lets us do some cool stuff a lot of this is collected from our other observability tool, Ken, which some of you might have been at the Seajure I gave a talk on or heard of it otherwise. But let's just like search for, across this system. Let's look for things with that particular trace. Oh, it's because I did this too long ago. That's what I get for preparing. Okay, so this was the only span in that particular trace. That's not too interesting. But you get the idea. You'd be able to see the logs going across different systems. And that's been super useful and actually made this tool by itself, like we had it before we kind of invested in good structured logs, and being able to send JSON to it made it significantly more useful as a observability tool for us. Let's see what else. Oh, I was going to show our actual production config. So the way that we actually consume Dialog, we have this Amperity logging project in our mono repo. It depends on Clojure. In this case, we want to also route anything built against Log4j into the same framework. So we pull in Log4j over SLF4j. We depend on Dialog and we depend on Ken, which is the observability tool. And here's some examples of how you'd like set the profile in different lining in profiles. And then in the resources of this project, we just write the config. So we've got dialog.eden, we do some custom init, and then for security, we have this blocked setting, so we don't ever want to log anything with this, and you also can't change this programmatically at runtime the way you can with the normal logger levels. And then we're going to run a couple of different middlewares, and the outputs look pretty similar to what you saw in the example. Then the namespace we're referencing there, Amperity logging core. So this is mapping Ken keys to the ones the logging system expects. Log event is what we're going to subscribe to the Ken TAC. So we're going to be taking all the observability events we get in addition to straight log calls, and we're going to call log event with them after some translation. And then collect context is really, I think, the secret sauce here, where Ken has this notion of context that can be collected either statically, like stuff at build time, or from the environment, such as information about the currently authenticated user or tracing information. And you can see we're kind of folding all that here into the log event. And this if conditional is dealing with the fact that some of the events we're going to get are from Ken directly, and some of them are just regular log events. And what we want is both for Ken events to get logged and for log messages to pick up the Ken context. So we're just doing a little bit of switching there. And then doing some extra formatting with the event information to customize the way the logs look. And then finally, this initialize call, we're not doing anything to the config, but we are subscribing to the Ken tap to do the event logging. And that kind of pulls everything together so that when you're running a service, you kind of get the best of both worlds. Just run this real quick. It's like, any questions so far? Wait, Fetterman's on?
Hey, sorry. Don't want to interrupt.
Hey, Dave. No worries. Good to see you.
I'm just good to see you too, man. I'm just catching up on this one.
Not directly related to the logging, but I was curious what you use for tracing.
So Ken is the predominantly an observability tool. Yeah, Ken manages the kind of dynamic trace context across everything, and then that gets surfaced in a tool called Honeycomb.
Okay.
Which let's see. Just want to see an example trace. Okay, sure. So this is like, you can see a call to one of our APIs. So OWL API here, and we got a bunch of fields on the event. We can see stuff like, oh, this was a put. The request size was 6 bytes, which is tiny. Request URI and so on. Information about who it was, what tenant it was in, and then kind of that comes down in a waterfall view showing what happens. So like, okay, first we had to authenticate the token, then we like loaded the tenant information, and then we made this compare versions call, and that took up a bunch of time. Okay, that also loaded some tenants, and you can see this going across different systems. And then ultimately, this was like a lot of time spent in the database before we were able to call this check rules function. Beken is the library that's kind of maintaining and producing all of the information we're sending here. Honeycomb is the like visualization tool in backend, which is very powerful. Definitely recommend. Okay, so this is a service, and you can see a bunch of logging happening as I start it up. It's waiting on the database, and this is using the same kind of REPL formatter as before. Oh, right, my laptop crashed. Okay, well, this is going to be too annoying to finish doing. Yeah, I lost some state earlier, but the experience as a developer for Dialog, I think, is pretty nice. And I don't think I have really any more to talk about now. The latest thing we're working on with Dialog is actually, this was a stretch goal of the initial project, is swapping out our usage of log4j in Spark, which requires a little bit of surgery to remove the log4j jar like after we've installed Spark, and then drop an Uber jar with Dialog and the config we want in place instead, and kind of trick everything to routing through our SLF4j backend, which has so far gone okay, but Spark is always a little bit of a hairy beast to deal with. But it'd be really cool to say that, you know, all of our logging is going through this simple, it's like, I think just under 2,000 lines of code for the whole thing, framework where there's like no room for security bugs or issues to hide. We have not gotten that far, Dave. Yeah, hopefully we can stay off. Yeah, happy to answer any other questions you guys have got, or other random stuff.
So is that like the last, some of the last pieces? My question was gonna be like, what was the rollout like, switching stuff over? How far along are you in that journey?
Yeah, so Dialog is currently version 0.3.1. I like to hold off on the 1.0 ceremony until Amperity has like actually adopted it internally. So as of today, Dialog is powering our logging for all of the cases we previously used Timber and Logback for. So like, we no longer have any dependencies in our code on those. And we have, I think in dev and stage, we're currently running Spark clusters that log through Dialog instead of log4j, and it's like baking for a little bit to make sure there's no issues before we roll that out in production. But hopefully in the next week or two, we'll be in a world where everything is going through Dialog, and then big 1.0 release and broader announcement. But yeah, so far it's been pretty smooth. The normal way we roll out things like this in a mono repo is like, for a while we have logging and logging 2, and then you slowly step through all the projects that depend on logging and like exclude that and start depending on logging 2, and eventually everything is on foo2, and you can delete foo and then rename foo2 back to foo, which is a process we've done a couple times now. Actually just killed off API base 2 like 2 weeks ago, finally, after like 6 months of slow migration.
That's always a good feeling, though.
Mm-hmm. Yeah, it's good to finish.
So I think as someone that I dabble in like Java and the specifically the Java logging ecosystem, but like I don't really have yet a mental map of like how all these moving pieces fit together. So if I understand right, we've got Clojure.logging over here, which is sort of like our front end, right? You call like Clojure.logging / like info or whatever if you want to log something at the info level. And then on the back end, you have things like Log4j or Dialog. And so those are the things that like kind of take those messages and then like put them somewhere, like, you know, into standard out or logly or something. And then but you can also have like SLF4j, which kind of like sits in the middle. Is that right? So like Clojure logging might go to SLF4j, which then goes to Dialog. Is that kind of how it works in some cases?
Yeah. And it's funny because Clojure tools logging actually, in a way, is a Clojure replication of the role that SLF4j is trying to fill. So Clojure tools logging, I'll use that as the like base of the analogy since you're more familiar with it. As you said, Clojure tools logging is by itself not going to print your log message. It is attempting to map a common set of interfaces, which in this case is a code interface, like literally a macro, to some thing that will do what you want with those log messages, with the understanding that lots of libraries can be written against Clojure tools logging and not make a decision about what actually does the printing, because that would be very annoying and hard to manage. In Java, SLF4j is trying to do the same thing, or is doing the same thing, where they publish SLF4j API, which is a jar that just contains these interfaces and the mechanism that finds the thing that does the backend job. And so lots of code can be written against SLF4j API without picking a backend. The funny thing is Clojure tools logging has this same kind of like, try this, okay, now try this, okay, now try this, like fallback mechanism to like search through the space of logger backends by dynamically requiring a class that's only in that logger. And if that's found, then it does that. And the first one it tries is SLF4j. So the common case, the one that we fall into, is that Clojure tools logging binds to SLF4j, and then your choice of backend is whatever SLF4j picks. The very gross thing, one of the gross things about Timber, and the reason like we didn't try and stay on Timber and like make it do what we wanted, is the way that Timber integrates with Clojure tools logging, because obviously Clojure core doesn't know about Timber since it's a library, is that Timber goes into the vars in Clojure tools logging and alters the root bindings at like boot time to say like, no, your backend is Timber. Which works, but didn't feel great as a implementation to be relying on, and had the problem I said earlier of like, in order for that to work at all, you still have to make this runtime, like boot time call to Timber to tell it to install itself. And that means your code like must depend on Clojure or Amperity logging core, like from your main namespace, or else like logging didn't get initialized at all. Whereas the SLF4j mechanism is like much more automatic and kind of like just works because it's done by when the class gets loaded.
Yeah. Okay. I think my mental map is a little bit clearer now, but it's a pretty complicated space.
Yeah. So having SLF4j, having a layer of Java in the middle, is like a little extra work if we were only interested in like pure Clojure as a solution, but has the benefit that you know, Java can be on this side logging through SLF4j, and we also get to handle it here. So stuff like one thing that did not work in our previous system that works now, which is really cool, is that you can be deep in like some Java library and it'll do a log statement, and that log statement will pick up like the trace you're in and the span you're inside of from the Ken metadata that surrounds that call, which was, you know, not at all possible with the previous system. So that's really been cool to see.
Yeah, that's pretty cool.
So yeah, but it was a couple weeks of hacking and then a significantly longer period of actually switching our code to use it. But we're almost done and it's gone really smoothly so far and no performance issues, which is another main consideration. So yeah, give Dialog a try.
Yeah, thank you. Speaking of performance though, was the Java stuff added later because you were hitting performance issues, or did you immediately know it would become a problem? And
it started mostly as just it's easier to implement. At least I find it easier to write Java to implement something like the slf4j API than it is to write Clojure in gen class to like emit the right forms to like bind everything. And even in the gen class case, you're still paying performance overhead for Clojure because the bytecode it emits is actually like just pointers to vars in that same namespace. So you still wind up having to like go resolve a var and call the Clojure code. So I kind of had performance in the back of my mind, but honestly, it was more just like I was a Java dev before I was a Clojure dev, so it was easier to write that and not have to kind of jump through the mental hoops of gen class to get it to fit the right shape. But then later did kind of make use of a bunch of Java isms to do caching, because like the most expensive thing that you might potentially do, I guess two expensive things you might do for a log message happening somewhere in Java land is one, you might need to format the message. And so there's a lot of, you know, if level enabled checks before you do anything with the arguments, which is pretty standard practice. But two, like figuring out what the level is honestly surprisingly large chunk of the performance hit for a log. And so part of what was painful in the Timber case was that that check was happening dynamically for every single call. So like if I had configured you know, warn for foo.bar and you're in logger foo bar abc xyz, like the check, is there any level setting that is a, you know, proper prefix of this logger, and like, oh, what's the longest one because that's the most specific one. Like it's not a lot of logic, but it adds up when you're doing it over and over and over again. So a lot of the caching is around keeping that calculation as close to the edge as possible. So like once I've resolved it for this class name, then I can reuse that, and then having a mechanism to communicate a change, because Dialog lets you alter levels programmatically, which is another cool bit of functionality that we use in our services. So there's like an administrative interface you can go to and say like, you know, I would like to temporarily change the level of logger foobar baz to debug in prod because something's going on and I need to investigate it. But when you do that, you know, you have to go and validate all those caches in the various loggers to make them check again. So it's not like crazy complicated, but it is. It seems to be effective, and we haven't noticed any performance degradation after the switch.
It's really neat. It seems like it keeps some of the like Clojure style too. You know, I could totally see being like, all right, we need to make this more static or cache it for performance, and then people just leave it right there. But that you actually like went the distance to, you know, make it a nice implementation. That's cool.
Yeah. Yeah, like I said, we had settled over the years on a fairly, I think, good set of functionality to have, but we were doing it by cobbling together all these different pieces in like pretty horrible ways. So the ability to like, okay, we see the outline of the shape very clearly. We just, what is the smallest thing we can build that makes that shape? So it was a fun Hack Week project.
Not a Hack Week project anymore.
Well, not anymore, yeah.
Is that a dynamic logging level change called out in the documentation, or should I go through the API to find that?
That's a good question. I don't actually think I did call it out. So that would be a good thing to add. Looks like Clojure doc is broken. But in that core logging namespace or dialog logger, there's a couple methods for introspecting the configuration. but there's a set level. I guess I'm not screen sharing anymore.
Yeah, I found it.
Yeah, there's a set level function, which will, you can change either the root level or since the config is just like a normal Clojure var, we can go associate that level in and then reset the cache so that stuff recomputes. And then you can check what the current levels are, which we use in that same kind of HTTP endpoint to, you can like ask what the log levels are in the service right now. But yeah, should probably add that to the README.
That's a very awesome thing. I was actually just discussing with a coworker the other week, wrapping some feature flag around a log statement that
Oh no,
enable for prod debugging and is all sorts of bad things. So
the I guess another thing I didn't call out. Yeah, I should probably write more docs for this. The middleware functions get called not just with the event, but with the config map as well. So if you wanted to have more dynamic control like that, for example, you could inject some stateful reference to your feature flag system into the login config and then have some middleware that turned it on or off based on whatever state was relevant in that. If that's an easier path than like wiring up something to call set level or clear levels directly.
right. Yeah, but still, definitely.
So you've solved observability and then logging. What's next, Greg?
In the open source space, that's a good question. There is more of our code base I think we could open source, some stable parts that have been around for a while. I don't know what's next. My mind is pretty occupied with the swapping out our entire storage architecture right now.
Sounds interesting.
I think the Parquet org libraries that we have, if we could clean up and make it open source, I think that could be fun.
Yeah, it's good staples.
Thanks a lot, Greg, for the quick run through on Dialog.
Yeah, happy to always happy to present, and it's enjoyable to get a chance to do some more open source work, because I mean, we're obviously not the only company in the world that wants to do logging, and somewhat selfishly, I wanted something like this that I could drop into my own like personal projects and have something easy to configure that I didn't have to worry about. So yeah.
Cool. I'll stop the recording for now.